Alright, let's look at a different example. So this is a 3 by 3 example. So x prime of t is this matrix times x of t. Okay, there's no constant term, so this is a homogeneous equation. Okay, so again, we're not going to learn how to solve this equation in this section. We're going to learn how to solve this equation in 7.3. So right now, we're just going to check these magically given functions are solutions. Are solutions. Yeah, we're not going to check all of them. Let's check x2 as a solution. The procedures are the same for all three of them. So let's check x2 as a solution. So let's check the left-hand side, which is x2 prime, which is 6e to the 3t, 0, and negative 3e to the 3t. So that's the left-hand side. And the right-hand side is the matrix times our vector x2. Okay. So the first term is 6, middle thing is 0, the last thing is 0, so just 6e to the 3t. And the middle row is negative 2, 0, 2, so it's 0. And the last term is 0, 0, negative 3. That looks at the same thing, so it checks out. So x2 is a solution, and it's similar for x1 and x3. Okay, so now we need to check their independence. So to check their independence, we need to check the Wronskian. So the Wronskian is the matrix with x1, x2, and x3 lined up perfectly next to each other. So it's 2e to the t, 2e to the t, e to the t. Oh, determinant. Determinant, and 2e to the 3t, 0, negative e to the 3t, 2e to the 5t, negative 2e to the 5t, e to the 5t. Okay, so the trick with determinants, you can factor the common terms out. The first column obviously has a common term, and the second column also has a common term, and the third column also has a common term. So you can factor all these out, and what you have left is a matrix with all the numbers. 1, negative 1, 1. Okay, so all these three combined together is e to the 9t. To calculate this determinant is 3 by 3, so it has 6 terms. Let's do that. So top left to bottom right, this is 0, and this is negative 4. This is also negative 4. Those are the 3 positive terms, and the 3 negative terms. This is 0, this is 4, and this is 4. So this is e to the 9t times negative 16, which is never 0. So the three solutions given above are linearly independent. So the general solution. Is of the form x equal to c1 times x1 plus c2 times x2 plus c3 times x3. Or if you want to write it out, it's function x1 is 2c1 e to the t plus 2c2 e to the 3t plus 2c3 e to the 5t. And x2 is 2c1 e to the t, and there's no middle term, minus 2c3 e to the 5t. And x3 is c1 e to the t minus c2 e to the 3t plus c3 e to the 5t. So that's the general solution. Let's move this up again. And if you are given initial conditions, so initial conditions can look like, if you want to save writing, you can say x, the vector x of 0 is equal to 0 to 6. Well, that means, this means x1 of 0 is 0, x2 of 0 is 2, x3 of 0 is 6. And take this thing above here, plug it in, we get 0 is 2c1 plus 2c2 plus 2c3, 2 is 2c1 plus minus 2c3, 2c3, 6 is c1 minus c2 plus c3. So basically we're trying to solve a system of linear equation looking like 2, 2, 2, 0, and 2, 0, negative 2, 2, and 1, negative 1, 1, 6. Alright, let's do this real quick. Get rid of all the 2's. So divided R1 by 2, divided by R2 by 2. So 1, 1, 1, 0, 1, 0, negative 1, 1, 1, negative 1, 1, 6. And then negative 1 R1 plus R2, negative 1 R1 plus R3. So that's 0, negative 1, negative 2, 0, negative 2, 0, 6. This is 1. This is 1. And the third row looks better, so let's move it. So swap R2 and R3. Also divide that, after swapping, divide that thing by negative 2. So 1, 1, 1, 0, 0, negative 1, negative 2, 1, 0, 1, 0, negative 3, and almost done. So R2 plus R3, 1, 1, 1, 0, 1, 0, 1, 0, negative 3, 0, 0, negative 2, negative 2. Okay, and this is enough to give us solutions. The middle one tells us that C2 is negative 3, and the third one tells us C3 is 1, which tells us that C1 minus 3 plus 1 is 0, so C1 is 2. Okay, so the particular solution, the final solution, the unique solution is x1 equal to 2c1, that's 4 e to the t, plus 2c2, that's minus 6 e to the 3t, plus 2c3, it's 2 e to the 5t, and x2 is 2c1, that's 4, minus 2c3, 2, and x3 is c1, that's 2, minus c2, that's plus 3 e to the 3t, and oh, I can't see it, plus c3, so that's plus e to the 5t. So that's our solution to the system linear first order equations.